400 some characters.
Oh, the real phonetic alphabet, like the one where you actually learn how to pronounce other languages.
Yes. I was a linguist.
Oh, you were?
Yeah.
I've had about like, 1 or 2 50-minute class periods learning that. So I'm at least familiar with it.
Excellent.
Well, welcome to the Tangerine SDR ham-sci technical session. My name is Dave, KV0S. And this week I've been actually cleaning up and we're busily working on plans for the Tapper DCC meeting and making sure we hope that it'll all go off smoothly. So that's when most of my time this week's been. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Well, I've been keeping busy. I'm getting ready for Tapper myself, Tapper DCC. I updated the ham-sci workshop website from last ham-sci workshop. So now if you go to any of the links, you should see the video embedded right in the talk, right in the page for that particular talk or presentation, as well as the PDF of the slides that people gave. So that's all updated. The ham-sci workshop grant proposal for next year is in the last stages of review with the University of Scranton before it gets submitted to the NSF. So hopefully we'll actually be able to make that submission this week. We had a club fair for the W3USR University of Scranton group on Friday. And so we were able to get many of the students that you've met through this telecon. They showed up, manned or personed the table at the club fair and are trying to get new students. So we're doing that. We got a buddy pole antenna that we set up at the club fair too, so people could see what a portable HF antenna looks like. And tomorrow morning, I'm going to be giving a lecture on ham radio and space science, the introduction to physics and engineering course. I'll be doing that 3 times this week. So I'm keeping busy. So
very good.
W2NF back to net.
Next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. I've been busy here. I completed preparing the couple of different video presentations for DCC. Didn't give me any place to submit them to yet, so I put them into a UA box and gave John Ackerman access to it. So he's going to download from there. I've been busy the past week doing the first set of software for the geolocation of all of the PSK data and experimented with doing all of 2015 and 2016. I found out there's a little peculiarity with the way that works. What comes from Phil Gladstone's system is a SQL build package, and sometimes the spots are out of order flowing from one package to the next. So when you geolocate them, if you want them to be in order, you have to combine ones from multiple days and then sort them down and then break them out again by day. So that, anyway, I've got a lot of the software prepared, or at least in 90% designed to do that. So that's going to be a fun job over the course. Well, we've got about 10 billion spots to geolocate sometime. That's, according to the project plan, need to be done in 40 days. So 40 days and 40 nights. I'm not sure how well it's going to work, but we're giving the old college try. Back to net.
Well, fine business. Next on the list, we have David, N1HAC. Go ahead, David.
Hello, everyone. Spent the week working on our various ongoing receiver projects and looking forward to the ARL Ham exposition this weekend in Marlborough, Mass, where Phil Erickson, I'm looking forward to him giving the keynote, well, not keynote talk, but the banquet talk on ham-sci and haystack. So back to net.
Well, that should be interesting. Next on the list is David Waugh, KE8. Oh, you've got extra letters in there. QEP, isn't it? Is it
Oh,
OP?
okay, yeah, I'm, well, it's more letters the better.
Yes.
I should fix that. Not much to report. I'm in the process of working on determining some of the best magnetometer settings. I discovered that there is 3 to 6 amps going through my ground rod, which persists after I disconnect, shut off all the circuit breakers. So I've been trying to track down. That's a fair amount of amperage going through the ground rod. That was a little distracting, but other than that, back to net.
Well, good luck in finding that. And it's not something you want to keep going, I am sure. Next on the list, we have David Witten, KD0 EAG. Go ahead, David.
Hello. Yes, I've been working on some test code for Scotty for the magnetometers, for the ones coming available, and I'm also been working on something else. Oh, that talk, yes, for the DCC. So those things have been keeping me modestly busy.
Yeah, I just
That's it.
comment is that I believe next week John will be sending you an email with the link to the Dropbox. We're having a meeting tomorrow, so it should be forthcoming soon.
Okay.
Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Just found David's comment about all the ground currents interesting. Just a reminder, don't disconnect your system ground and get between that from hand to hand, because it only takes 40 milliamps to stop a human heart. So I used to have to read electrocution studies back in my working career. So that stuff is near and dear to my heart. So be careful. That's all. Back to net.
Well, thanks for the advice. And next on the list is James, KG4 DSG. Go ahead, James.
Good evening, Dave and the group. I broke into the piggy bank today and purchased my DCC tickets. I think I could afford them. Not sure about the travel arrangements yet, but I'm working on it. Back to the net.
Well, fine business. And next on the list is Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. It was a fairly productive week. If you remember, last week when I did my presentation, there was clipping on my pulse per second pulse, and I was able to fix that this week. What I did, I explained it in the email that I sent, and I sent a screenshot of the pulse. There's a potentiometer on the audio injector stereo sound card, and what I did was I just simply used that, and Paul, the author of ELFRX Tools, recommends that the GPS pulse be around 80% of the sound card input. So what I did is I used the scope and another utility called VT-Stat to look at the screen to show any peak voltages, and I was able to get it down to 80%, and I have no timing errors. So the timing is now clean. I do have, I can see that when I put the cover on the enclosure, when everything heats up, the mean absolute distribution of the PPS pulse as compared to the system clock it tends to deviate as the system heats up and the crystal changes frequency. But it's not really much cause for issue. It's still within limits, so everything works well. What I also did was for the VLOF audio channel, I desoldered the ground connection, and I shorted the input and the wiper, so the VLOF audio gets bypassed and does not go through the pot. So the system works pretty well now. And another exciting thing that that I started working on is an H field receiver. This is going to be dual channel. It's going to be both north-south and east-west loops. It's also going to be powered with a isolated DC-DC converter and audio isolation transformers in the line. The original circuit also came from Paul. He originally designed it for a group in Taiwan, the TNU group, who were doing a study on tweaks, and he originally designed the circuit for them because tweaks and whistles tend to be stronger in the B field, so they're better. It's a better receiver to use. So I'm kind of working on the circuit and the layout and the box and everything else. Other than that, back to the net.
Well, fine business. And next on the list is Michael, AAAK. Go ahead, Michael.
Well, thank you very much, and greetings to everyone listening. Back to you, Dave.
Okay, next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Well, good afternoon, good evening, Dave. Everyone, been working with Dave Whitten a bit on testing for the magnetometer boards that I have in hand now. I have the prototypes, the 10 prototypes in hand. So I got to get to work and get them tested and programmed and out to people to test. What else? Working a little bit on the proposals. They wanted some more information on the big picture for the personal space weather station. The ARDC people did. So I worked with Nathaniel a bit on that, got that going, and trying to get ready for an actual real vacation next 2 weeks. So actually be able to go somewhere and do something before hopefully the house starts getting under construction, in which case I won't be able to go anywhere and do anything outside of home. So looking forward to that, trying to get everything tied up, some loose ends tied up before then. So I guess that's it for right now. Back to you, Dave.
Well, fine business. And next on the list is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave and everyone. I've spent this week looking for packages for the Max 10 FPGA development board. And I think I've had some luck with one package, at least finding all the pieces. Many of the packages are kind of 5-6 years old and the links are dead. And I've managed to find the source code. I haven't installed it yet. It's called Rocketboards, and it uses the Ethernet DMA controllers, the Nios 2 processor, and the software is embedded Linux, which it loads onto the QSPI flash memory. And I found the source for that. It appears to have the drivers for all the peripherals. And so short of actually getting it to build and work, it looks encouraging. So I'm going to give that a try. I've got binaries to load the hardware and to load the embedded Linux into the flash and give that a try. One tool appears to be missing, and that is the Linux builder, but it appears that GCC tools may have caught up and do that function now. So if true, then that would be a good thing. So I'm going to load the binaries and see what happens. And if that's successful, then I'm going to dig into it a little bit more, but trying to get a working set of code, hardware, and interfaces. And if we get that to work, then we at least have a place to start the project from rather than trying to do it from scratch. I was particularly worried about the device drivers. Back to Ned.
Well, fine business. That's a real find if they all work out. So, okay, well, we're a little shorter, fewer people tonight. So that's the list, I believe. So we're open for general discussion.
So I should ask questions. Do we have any embedded Linux experts in the group?
I don't think my Linux, I have good Linux skills, but they're not embedded Linux skills. And
Embedded.
there are probably people in this group that have better Linux skills than I have.
Does it have a brand associated with it, or is it just their version?
I think they've adopted some of the tools. As far as I can tell, it looks like the embedded Linux is related to BusyBox.
Okay.
Was a kind of a predecessor to Alpine or something like that. So it looks, it's a BusyBox like thing. But I downloaded the source from GitHub, and it appears to have all the drivers for the peripherals on the in the FPGA. So it can talk to the Ethernet controller, that talk to the DMA controllers, and especially being Linux, the processor needs memory management, and so it has to use the version of the processor with hardware MMU, and it appears to have drivers for that as well. So there's one tool which I think GCC may work for to compile it, and then you use a package called build root, which builds the root file system and packages up the boot and all of that stuff in the image. One complexity, the code is resident in the QSPI flash on the board. Are you listening, Scotty? And so what it means is to get it up, you have to load a loader into the FPGA, and then that loader has to load the embedded Linux into the QSPI flash, and then you have to load the FPGA image. So it's kind of a fairly complicated load process. If it doesn't, the console, it uses the serial port on the Max 10, not the JTAG, but the serial port as the console for Linux. And from there, you apparently can use things like wget to load software through the Ethernet interface into the image. And so, it's got all the nice things that come with having Linux, and the nice things like being able to deal with sockets and things like that. So I'm keeping my fingers crossed that it still works after 5 years.
So how much QSPI flash does it take?
I have no clue.
Okay, we ought to be sure we have enough.
Yeah.
Does it have any kind of external file system, or is it all embedded?
I think the file system's all embedded, but you can load. There's one example where they use wget to pull a package from the web into the embedded file system and run it. And so I don't know if that, I think that's going into DDR3 RAM that's on the board. And but I haven't looked into what parts of memory get allocated where, and that's still for further work. It's the heaviest weight solution that I found, but it's the only one where I was able to resolve all the dead links and get the packages.
Yeah, because I think we have 512 megabits of QSPI.
Okay.
I'm looking to make sure it is somewhat adjustable because you can drop in whatever size you have enough money to pay for.
Yeah.
And you can actually buy.
Yeah, I haven't looked at the Max 10 development board to see how much that is. I need to check that because it runs on the It runs on the Rev C development board.
Oh, it does run on our boards then, the ones that we have?
Well, it runs on the Intel Altera development kit.
Okay, that's different than the one we have.
Well, this is the one with the HMAC connector.
HSMC connector?
Yes, yes. It runs on that, the board that I bought from.
Okay, the $200 board.
Pardon?
The $200 board that we bought from DigiKey, right?
Yes, it runs on that board. In theory.
Okay, let's see. I'm looking the data sheet up now to see what we actually bought. Because these parts are sitting in the next room, so so obviously we can get those particular ones.
Mhm.
Oh, I'm still looking to see. Oh, there it is.
512 megabit Q-SPI flash.
Right, it's yeah.
On that board.
Guys,
So
I'm going to make it a short night tonight because I've got to drive to Pensacola tomorrow, but 73, and we will see you next week.
73.
Good seeing you. Take care.
73, Bill.
Yeah, and I believe it's the same part that we use. Just
Okay.
one second here, I will check it. Because I've got the schematic for our board. I mean, for the development board that we all use.
Yeah.
And Q-SPI flash. Yep, same one.
Okay, good.
It's
So
works out to 64 megabytes. Not a lot.
It's 512, so 64 megabytes. Yeah.
Yeah, a lot of the appliances you see use BusyBox on them, and I think those fit in 32 megs or 64 meg flash memories.
Is there a requirement for RAM also? There probably is.
Yeah, it uses the DDR RAM on the development board. I'm hoping that's very similar to what you've got on the plan for the data engine.
It's similar, but it's not the same because they use a 24-bit wide RAM and we use a 16-bit wide RAM. So we have a little bit less of it than they do.
Okay.
We, let's see, because it takes up lots of IO to use 24 bits for what I deemed was not much advantage.
Yeah, well, hopefully the FPGA DDR controller can be adapted to the different kinds of memory.
Yeah, it can. It's because it's DDR3, which is the same kind we're using. It's just that we're using a 256 meg by 16, so 512 megabytes is what we got, but it's arranged by 16.
Okay.
So
yeah, the processor sees it, I think, as a by 32, regardless of how the hardware actually.
yeah. So then it would be a 128 meg by 32, and it's really interesting because on the development kit they have a 64 meg by 16 and a 128 meg by 8 RAM.
Okay.
Now, how you make that into something usable, I'm not really sure because it seems kind of mismatched in size. I would think that you would want the same number of address lines going to each one, and you concatenate them so you'd have true 24-bit, but you got 64 meg by 24 bits, and then the upper 64 meg is only 8 bits wide. So I don't know how that actually works in the development board itself.
Okay. If I get to the point where I get it up and running on the development board, I'll see if the Linux tools will tell me, used and free and all of that kind of stuff.
Yeah.
So it's been a lot of detective work trying to find all the pieces.
Yeah. And one of the things I'm on this next grant request that I'm putting in momentarily here for the Data Engine Mark II is some pair of float licenses, full float licenses, because we're going to need them for the Area 10. but it sounds like we might need them for some of the IP for this particular, for the Cyclone 5. So at least you'll be able to run a full version of the Quartus tool.
Yeah, I've been trying to read through the license document, and I think the NIOS 2F processor with the hardware MMU and the Ethernet MAC may be covered if you have the full license. I think that IP may be covered in there.
Yeah, I think
If so, that's a big help.
I think all the NEOSs are covered, but the IPs are not necessarily covered under the free license.
Yeah, both IPs have what are called time limited, meaning they run for like an hour after you load the FPGA. But in reading through it, it looks like those two parts might be covered by the purchase license. It's really hard to weed through that license document and understand what it does and doesn't cover.
Well, the good news is the full purchase float license covers everything. So
Okay.
you shouldn't have to worry about any of the, although, well, it depends on what you buy, I guess, because there's some IP packages that are licensed separately. And my plan is to try and negotiate a deal with a full set of IP cores that will, everything will be licensed. So
yeah,
we'll see. I mean, the thing is that between ARDC and Intel, we may end up having to pay for the licenses, but we may end up getting a university rate or something because we're a nonprofit. And then we might get the extra IP for either cut rate or included or something like that as as part of the negotiation. So we'll see what happens.
okay. Yeah, my hope is that the files that come in the package were generated by somebody with a license, meaning I can't alter them or recompile them, but I can use the binaries.
Yeah.
And at least if that's the case, I can at least get some way down the experimentation curve before we need to go work that problem.
It's kind of silly to sell you a board with 2 GigE ports on it and then say you can't use the GigE IP without a license. That's, what's the point? But on the other hand, the 1 hour runs for an hour is maybe their solution, but I think that's a hokey solution. And I've seen another solution also that says as long as the development board is connected to Quartus, that'll run. But that means you can't put it in your own board because you don't have the development board connected anymore. So that is not a solution for us either.
Yeah, it was hard to resolve. I'm trying to read the error messages from the synthesizer and compiler, and both the error messages I get for the NIOS 2F and for the Ethernet both say time limited license.
Yeah.
And so I guess there's different error messages depending on what kind of IP cores you need to use.
By the way, it's pronounced NEOS.
NEOS, okay. I keep saying that wrong.
Yeah.
Anyway, we need the one that requires a license because Linux needs MMU paging to work.
Okay. So that inherently means that some of the NEOS versions are not licensed under the free license then.
Yeah, the 2E does not need a license, and it's missing most of the stuff, and it's quite a bit lower performance. The 2F has hardware acceleration and a bunch of things, and the key thing, as far as I'm concerned, is the MMU.
Yeah. Have you seen what an estimate of what kind of usage, LE usage, the embedded Linux is going to what it's going to use in terms of resources in the FPGA?
I built an SOPC image with the Ethernet interface, 2 DMA controllers, the processor, and I was at about 10% LE utilization.
Okay, good. I was concerned that we were going to use up all our LEs on NEOS and not have anything left for processing, but that's 10% is a good number.
Yeah, of course. And I don't have the IO, the status and MAC IOs wired up on the Ethernet because I don't know how to do that. You basically have to do that in Verilog.
Okay.
And so the synthesizer may have synthesized away some percent of the gates.
Yeah, it will if you don't connect it up to anything. So.
Right. So, and that's what when I first loaded the image for the hardware for the reference design, all I found was all the interconnect was exported and which means that it shows up in a Verilog file somewhere, and I don't have that Verilog file to look at. So I'll try to bring that up and see what the utilization is.
It shows up in the instantiation. So when you instantiate that module, you'll get those IO pins. And one of the things that you can do, now this is really cheesy, but just take the pins and connect them up to an IO pin.
Yeah,
It will not work, obviously, but if it's connected somewhere, it won't be removed. So at least it'll keep the logic.
I did that, and it increased the gate count from 10% to about 11 or 12%
Yeah.
of the LD. So I think we're in that 10, 11, 12 range for the utilization of all
Yeah.
this.
And that's I think that's a well of value. So it's worth the 12% of the part for the features you're going to get.
Yeah, I found some other packages that are much lighter weight. They don't have drivers for the DMA, which I think we have to have the DMA to run at 1 and to run at 10 gigs.
Yes.
And so the package I'm looking at appears to have the MMU drivers and DMA drivers, all of that stuff. So if that's true, the second advantage is that if we're able to keep it in a Linux-like environment with C code, we increase the audience of folks who can work on it.
Yeah. And if we go to 10 gig, we're going to have almost 10 times the resources. So not 10 times. We're going to go from 50 KLEs to 270,000.
Yeah.
So 5 to 6 times as much. And a lot more RAM, internal RAM also inside the FPGA, and a lot higher speed.
Yeah, and looking through it, I think what we're going to have to do once we get it working, we're going to have to instantiate Verilog logic to do the slow path, fast path packet classifier function, and unload that from the processor.
Okay.
So that packets coming in can be automatically decided whether they go to the RF module or whether they go to the processor. I think we don't want the processor trying to decide on a packet by packet basis where things get routed.
Right. So like control packets got to be looked at by the processor. They'd be slow, and then streaming packets would just be fed straight through.
Exactly. And so we'll probably have to put together some Verilog to go look at a rule table in hardware and then decide where the packet goes. And we got two of those, one for transmit, one for receive.
Hopefully we can look at just the header of the packet to decide what class it is.
Yeah, given the DE protocol, which is pretty complicated, I think the processor will have to set up some tables, and the Verilog's going to have to go look at the tables to see who's assigned to what to figure out how to do it. That, of course, is the advantage of it. It'll work at 10 gig as well.
Yeah. So have you had a chance to look at the adapter board anymore?
No, I haven't. I was kind of confused by the pin names, and I put it aside while I was working on other stuff.
Really, the way to do it is to look at the connector pin numbers, because then the names really mean nothing. The names are assigned for the general case, and then when you plug in a specific board, then the names all change according to that board, and then everything doesn't look like it's working or it's connected right.
Right. So I tried to go by the net names or the net labels rather than the connector names, and hope that's right. So I haven't dug into that any further, but it gets real complicated building an adapter board where there's a couple of things on the left side and a couple of different things on the right side. Then it's got to work in all cases. That gets to be a very brain scrambling exercise.
Yeah. But I got to get with our CAD guy, and he may be willing to do some work on the layout of that on speculation, because we don't have the money to pay for building anything yet. But hopefully when I turn this last piece of paperwork in, we'll get an answer from ARDC pretty quick, because it seemed like have looked at it and discussed it already, and they may be just waiting for this last piece of paper to go for it.
Okay. Yeah, it's there's a lot of moving pieces here right now.
Yeah.
So anyway, if I'm lucky and the binaries load, And the binaries are spec'd, as far as I can tell, for the exact Rev-C development board we have. So I'm confident that, being POF and soft files, they'll load directly. We can at least get something up. And I've got to figure out, I wrote a terminal in Python a couple of years ago for talking to the HP GPS receiver. And I'm hopeful I can just tweak that to talk to the serial port to get a console interface to the embedded Linux. If that's the case, then we can load and launch other software into the image.
So have you been able to instantiate the DDR3 controller and get it to compile?
No, I have not tried to do that.
Okay, because that was an issue that I had with the version. Oh, but you're running under Linux, right?
Well, if it's the embedded Linux, yeah, I believe it has the driver for the DDR built in.
No, I mean the compiler is running on Linux, not on Windows, right?
Yeah, the compiler that I'm running everything on Linux.
Okay, so you're running a Linux version of Quartus.
Yes.
Okay, so it should work under that version.
Okay.
It does not work under the Windows version.
Oh gosh. Okay.
That was
I did.
Go load Linux. That was.
Yeah, I did everything on Linux 20.04, and I wrote a document on how I did it and uploaded it to the Tangerine project under the white papers on how to make the software development environment actually work and how to get the because it doesn't straight out of the package, but I worked through it and got it to work. So there's a document showing how to build it all.
Maybe you ought to sell that back to Intel.
Well, maybe so. Yeah, it turns out there's some Java things in Java that are broken that are needed to make the software tool work. But I got that.
Does that have to do with the Byte Blaster, the USB blaster?
No. It has to do with the Eclipse environment. Eclipse needs Java to come up and run. But the problem is there are some Java version issues. And I ended up having to go in, use an old version of Java, and then create a bunch of symbolic links to repoint Java instances back and forth and around to bypass the problem packages. And I got that all up and running.
Jeez. And you're running.
Anyway, it works. It works.
Running, Ubuntu
20.04.
Okay. And
anyway, the document will tell you how to do that.
Okay, it's in the Tangerine.
Yeah, it's under working papers.
Okay. Because I do have my Linux box set up here now because I gave up on Windows for the FPGA because of their fine support.
Yeah, I'm not confident that I can get the model simulator to work. I tried to get that working. There have been reports of success on Ubuntu. You have to go add 32-bit architecture libraries to Ubuntu.
Yeah, it's a pain in the neck.
And I was not able to get that successful.
We got it working under Quartus. I believe it's 1801.
Okay.
A few years ago, and under the appropriate Ubuntu of that year. And it's a pain in the neck because you got to load a bunch of 32-bit stuff because it's not all 64-bit and it gets confused. So, not to mention us getting confused. But I don't know how it is now. It's probably, the same, only different. The same kind of problem, only a bunch of different places.
Yeah. So anyway, it was a kind of like a Sherlock Holmes kind of a week.
Yeah. Well, I'm glad to hear you're successful. That's an achievement.
I'll be successful when I get the binaries loaded and it runs.
Yeah. So when you can blink an LED with Linux, right?
Yeah, basically. Yeah, if I can blink an LED.
Or print a hello world or something.
Yeah, I've succeeded with Hello World, but not using Linux, just using I was able to software build Hello World and do a printf.
But that's just running C under Neos, right?
Yes, that's correct.
Yeah.
And that was all on the internal FPGA RAM. So the simplest possible case and just running it out over the JTAG interface.
Yeah.
So that was easy by comparison.
But believe it or not, you can actually run the Neos processor out of QSPI directly. You can
Okay.
believe that, loading nibbles at a time and
Whoa.
running the code. It's got to be horribly inefficient and slow.
Yeah.
I wouldn't plan to do that.
Yeah, my hope is that if all of this comes together, the Neos is just doing command and control functions and setting up data paths, tearing down data paths.
But all the drivers and such are going to have to be in RAM in the Neos that's running Linux.
Yeah, but the drivers, right? We need the FPGA to be offloading high-speed I/O, so
Right.
the processor's not doing that stuff.
But I'm just thinking that the amount of RAM that we have needs to be sufficient to load all of the Neos code for Linux into the RAM, external RAM of the FPGA. And of that we have like what I say, 128 megabytes.
Yeah, most of that RAM right now, I think, is going to be set up for the DMA controllers. Although I think we can adjust how much RAM we assign to the DMA controllers. Because that's what will buffer all the Ethernet I/O.
So you think when we go to the 10 gig part, we really need to have larger buffers, more external RAM.
Yeah, the packets at 10 gig, the packets come pretty fast and furious.
And they're big too, aren't they? They're
right. But I'm still right. I'm hopeful that, again, you just want the processor doing, command and control stuff. You want Verilog linking and unlinking buffers from chains. Basically, you want to have a bunch of buffer chains, and you have a slow buffer chain and a fast buffer chain, and the FPGA hardware takes care of that for you.
And the Neos just manages the DMA engines.
Well, yeah, it sets them up and then tells them go run your chains and have fun. Tell me if something bad happens.
But we have to have enough RAM.
Yes, well, we'll have to have enough RAM, and the RAM at 10 gig is going to be a lot more than the RAM at 1 gig.
Yeah. Well, on the ARIA 10, I believe we have hard memory controllers. So they're going to be much more efficient than the soft memory controller.
Yeah, at 1 gig, you've got, I think I calculated 15 microseconds between Ethernet interrupts for, a full frame just got received every 15 microseconds.
And that's sending an entire packet out?
Yeah, that's receiving an entire packet and the DMA engine interrupting, saying, I just got a packet. You get one of those every 15 microseconds. So if you try to handle that with the processor, there's not a lot of time to do stuff. At 10 gig, of course, it's 1.5 microseconds per packet.
And they're bigger packets.
Well, per 1500 byte packets. Okay. A 9K packet would be about 9 microseconds at 10.
So
gig.
is a standard packet at 10 gig still 1500, or is it larger?
Yeah, it's 1500 unless you go to jumbo packets. So jumbo packets don't care what the line rate is. They're either normal packets or they're jumbo at 1 gig or at 10 gig. They don't care about the line rate. They just care whether they're jumbo or regular.
So it just scales to the same. It's the same. Only it scales to the higher speed.
Right.
Which is kind of the reason why
jumbo packets are good in that those interrupts happen a lot less frequently.
So we just it just scales, which is why we did it that way. Boy, are we smart.
All I can say is I'm glad someone else wrote all the drivers, because writing low-level drivers is a real pain.
Yeah.
So, Scotty, I did want to mention I found all the unglued parts of a magnetometer tube kit. So I have them all laid out so I can take pictures before I glue them together.
So we really need to decide though on a standard way we're going to do it, rather than have, Jules doing it one way and you doing it a different way, and Dave W doing it a different way. And it's like, how are we going to do that?
I don't know.
And I
I'm
guess
gonna talk to Dave this week and maybe we'll get some idea figured out.
okay, because I'm going to be ready to ship these to you guys here pretty soon.
Yep.
And in fact, yeah, I'm thinking I probably will not wait for Dave's software to do this, because
On the first
ones,
ones
I'll send one to Dave, and then Dave can test it on a real board.
Yeah, I'm not sure I can really make the software completely without something to
Not
test
having a
on.
real board, right?
Yeah, not to do the ID, the serial number,
Yeah.
I can simulate the rest. I don't think the boards, any of the boards I have that serial number chip on them.
Yes, you have a Tapper Rev D board, right?
I guess I do.
Yeah, it has it on there.
Okay,
There's a
well,
jumper on there to enable the writing of it.
a jumper. Oh, okay.
This is the write enable jumper, the REN jumper.
Uh-huh. Uh-huh. Okay.
As somebody pointed out, we have birds on there, right? We have REN and
Oh,
we have,
yes, the Ren.
Ran, yes, the right
Yes.
name. Okay.
and then I forget, there's another one or two that are
So
more of a
Scotty,
stretch, but
you can send those boards to Dave in one box instead of sending
Okay.
us separate
Yeah.
boxes.
I was hoping to do that. And yeah, then you can split them up on your weekly meeting or whenever you guys get
Yeah.
together.
I promise.
And we have, I have sensor boards and everything, so that they're all complete. They won't require you to have anything except the mechanical pieces of the tube and all that,
And a soldering iron.
and a soldering iron, and no SMT soldering. All easy 10th inch center through hole stuff.
Good.
All right, so did that, I think it sounds okay, because even though the test setup that you will be testing will not be a normal setup, because it'll have RM3100s on both ends, I think in order to make sure that we cover the outgoing differential bus, we really have to talk to something outside on the bus to make sure that works.
Mm-hmm.
Because we're just covering solder joints right now. Because
Yeah.
I don't care about it. If it doesn't work, it's because the parts burn out, and that's not going to pretty much be the case. But it's much more likely that we'll have something not soldered right, or a cold joint, or
Sure.
a missing part, or something like
Yeah,
that.
I really think we need to test make sure the data is flowing through the 9615s. Because
Right.
that's really the weak point in the whole deal.
And I think if we set one board up for a local, and we talk to a known good remote,
Uh-huh.
then if it works in the local configuration, then if you were to put it in the remote configuration, it would still work, because you tested it's all the same paths.
Uh-huh.
So we don't really need to test the board as a local and as a remote. We just have to test it to make sure we talk over the wire.
Right.
And if we do that, and we can talk to both temperature sensors and both RM3100s, then it's good. And
Yeah.
we can program the ROM too.
Yeah, but programming the ROM's going to have to be as local, because
Right.
that's on a different I2C bus that's not routed out across the.
Right, so it's on the 40 pin connector. So,
Yeah, yes.
yeah, so it has to be on local. That's why I think the device under test has to be local. And I really don't want to do 2 steps for 500 boards.
Uh-huh.
So if we can do it in 1 step and test everything that we can, and it's sufficient, it would be much better.
I think that should be practical.
Because I know on the HPSDR boards, we built 650 Aussies and 650 Janices, and each one had 2 tests. So we had to, and it took more time to plug them in and wire up all the loopbacks or the actual cables for the system than it took to actually run the test. So you end up wearing your fingers out, plugging and unplugging cables and boards. And the test is like click, pass, so it was very fast. And I'm sure yours is going to be the same way, right? Because I think the ROM write is going to be the longest time.
Yeah.
I don't know how long that takes.
I don't either.
Seems to me it was almost instantaneous. Very
I don't-
small ROM.
I doubt it. I doubt it's very long.
Yeah.
But are you all right with a command line type utility that just loops around every time you put a new board on it? It goes through its test. You click OK. It goes through its tests. If those are okay, it says burn ROM or something. You say yes, and it does that, and then you unload. You put another board on and do it all again.
Yeah,
Is that good
ideally,
enough?
you don't want to have to reboot the Pi in between.
I'm not, hopefully won't need to. I have seen the buses get confused, but I don't think, I think if you're not as fumble fingered as I am, it will probably work.
I don't know.
And
After
just about
500,
anybody ought to be that.
after 500, I might not be so
Yeah,
swave and deboner,
yeah, yeah.
But I think that the idea would be is to not have any intervention. So, but a command line interface is great. That's perfect. And if we can just loop it, so it can say, stop and wait for me to hit a key to start the test, which
Yeah.
means I got the board all set up and ready to go. I can hit enter, and it runs through and it says programming ROM, verifying temperature sensor, a couple of status lines maybe, and then either test bad or one of those failed, or test okay, and then loops back around and waits again for another.
Okay. Yeah, and it doesn't need to print out a serial number sticker or anything. to
No.
go on the words. Okay.
Yeah, I think that's beyond the Call of Duty to try and put a serial number sticker on each one. If you want to see the serial number, put it in your Pi and read the ROM.
Yeah. Okay.
And interestingly enough, the way that they guarantee that the serial numbers are unique is they say, well, we're just going to randomly pick one out of the 72-bit field, and and most likely it'll be unique. And so because I was wondering how they assigned them, and they basically assign them at random.
Uh-huh.
And they
It's like
depend upon the
big
randomness.
sky theory.
The what?
The big sky theory.
How's that?
That's how they used to do aircraft separation. They just assumed that the sky was so large that no aircraft would collide with each other.
How did that work out?
Not well. They don't use it anymore.
It
Yeah,
doesn't
remember
work out when-
Tenerife? Yeah.
I think they stopped using it in the 1950s.
When you get cities with congestion like we have, it doesn't work anymore.
No.
So anyway, I have not documented on a board that you guys have gotten the number that's programmed into it, but it's basically a text file. It's an ASCII file with all the parameters set the way it's supposed to be set for the particular board, by what the spec for the file structure says, and then they just insert the serial number at the beginning.
Now, have you got that text file?
Yes, I do.
Okay, and could you email it to me?
Yes,
So
I can do that. Yeah.
that'll be.
All I
very
did
good.
is I went and Googled the Raspberry Pi ROM, how it works.
Yeah,
And
I know where it is on where the instructions and the code are. I've seen
so
that, but
did you find the programmer? Is it written in something easy to?
oh, I remember, I think seeing one that was in C, and I might have to translate it to the way I'm doing I²C or something, but because I'm using a pretty basic way rather than the most efficient.
I don't remember whether it's in Python or C, the version that I found, but
Doesn't matter much. They look the same to me.
it was pretty straightforward though. I mean, it worked right out of just follow the instructions that they had and it worked. So
Yeah, great. It's not that many boards are putting them on anymore. Doesn't seem like, but.
so maybe we should not bother? No, that's not.
No, I'm not saying that. I think it's a good idea to be able to.
Well, it's interesting if you look at what's in the file that you program into the ROM, it basically tells you the direction of what needs to be the direction of every IO pin that you use on the board.
Uh-huh.
So it's kind of like instructions on how to talk to the board, not the format, but it tells you that's an input, that's an output. These are unused. This has to be open drain. That can be totem pole.
But it doesn't really act on that information on its own.
No, it just gives you the information, and your driver is supposed to be able to interpret.
Yeah,
it if you
that's
want.
nice. That's nice to have.
Yeah, so I thought it was good, and it's so inexpensive. It's more of a pain in the neck to manufacture than it is anything else.
Right, right. But it shouldn't be a problem.
Shouldn't be a problem, as long as someone else is doing it. So I'm going to try to find someone else to do it, and I'll be all set.
Listen to the
Well,
train,
the
train
50
whistle there.
I did the 50 boards, and this is only 10 times as many, right?
Right.
So how much harder could it be?
About
10 times, right? 10 dB.
10 dB more. Yeah.
Well, I need to go. So I'm going to say 73.
Yeah, I think I will too. Or
me too.
Me
Thanks,
too.
Dave and Dave.
Scotty, can you check your email and get me that part number for
Oh
those?
yeah, I owe you a part number too. Wasn't there something else that you asked too?
If you had it, it was the pinout for the leaf module.
Yep, I got that. So I'll send that to you also.
Okay, thanks.
Okay. That yeah, I think that we actually changed the regulator from the one that you found, or maybe it was the one that you found that was the best one. We changed it 3 times, I remember.
No, it was the one from onsemi that was just as good, but a little cheaper. It was just as good as the one from TI.
It had the same low noise.
Yeah.
Because let's see, looking it up right now. Where is the?
You said that you used it on the data engine and also the clock module.
Yeah. So it's 18 microvolts RMS noise at, I think that's at full output. Okay. I'll give it to you, the part number right here if you want it.
Okay.
As soon as I figure out how to run my computer. Okay. There you go.
Perfect. Thank you, Scotty.
And they make 1.8 volt versions of that too. So.
Right. Yeah. Yeah.
And the other one we used was a TI one. Interestingly enough.
That TI one, that was the one that was present on the evaluation board, and that was a little bit more expensive.
It's a little bit quieter, but yeah. So let me give you the part number for that one too, and have you look at it, because you might decide you want to use this part number. I'm using the on semiconductor part number for on the clock module to power the GPS.
Okay.
Power the analog circuitries, the oscillators, and the synthesizer. I'm using the TI part because it's quieter.
Oh, are you?
Yeah.
Oh, that's the one that I gave you from the evaluation board, right?
Probably. I think that's correct. Just a second here. Let me. Okay. Here's the part number of that one.
Okay.
Those are the 2 that we use on the clock module. Again, the on semiconductor for the GPS, and the other 2 are the TI ones.
All right. Okay. I got those written down. Thanks. Yeah. I'll double check, but I believe that might be the one that was used on the evaluation board, but I will double check.
Yeah. So we use 3.3 volt ones and a 1.8 volt of the TIs, And then we use the 3.3 volt on semiconductor one for the GPS and for the external antenna power to power the remote antenna.
Okay. All right. So then what I'll do is I'll use the 3.3 volt version for the analog power of the ADD converter, and the 1.8 volt version I will use for the IO-VDD.
Okay.
And that should take care of it.
And let's see, I'm trying to think on the RF module too. We used those because we swapped out one of the big noisy ones with two small quiet ones. Just 1 second here. Let me.
All right.
Find this one on the RX module. Okay, so we use the. I use the on semiconductor ones on all three positions for both 1.8s. The 3.3s. We were using like the LD1117, but they're a lot noisier than these.
Oh yeah, definitely.
So these are much quieter. And we have a lot of extra filtering too. So Tom put that in.
Oh, all right. I will because I was, depending on what you recommended, and based on cost, but since you do use the TI part number, maybe I'll stick with that.
Yeah,
what would you recommend?
Hold on, say what?
What would you recommend? Should I use the TI LDO or the one from onsemi?
Let me see how many DigiKey has before we do either of those. Okay, the TI part. They have 859 in stock, and in hundreds, they're $126.
All right.
That's for the TI part.
Right.
And the on part. Hold on a second. Where did my chat window went away? I hate this thing when it's full screen. It blocks off everything else. Okay, the on one.
All right.
These are 3.3 volt ones. Oh, they don't have any of those.
Huh.
I guess you ought to use the TI since you can't get any of these from DigiKey anyway. Let's see if
I believe those on semi parts, those are sourced from Asia.
Yeah, okay. Mauser has 10,000 of them in stock, and they are 95 cents in hundreds of the ons.
Okay.
So, like I said, look at the data sheet, look at the noise output of them, and you see that the TIs are a little bit quieter.
All right. I think, well, yeah, I remember you saying that. That might be, so compared to the linear, the TI and the onsemi, I think our best bet in terms of cost and noise is probably the TI part. Yeah, because the parts from linear are much more.
Yeah, they're pretty proud of their parts.
Yeah.
I mean, they work well, but let's see.
Yeah.
Okay, so Mauser has 3,500 of the TI parts in stock, and they are $139. So the TI parts are a little bit more expensive, but they're a little quieter.
Okay.
So I think I would use them on anything that for the analog for for the digital IO inputs,
Yeah.
sorry, for the analog inputs, like the A to D converter, any of that, VDDAs, I'd use the TI part.
Okay.
And then the on you can use for anything, for any of the digital stuff, you can use the on for.
Okay, sounds good. I'll use both then, because I wasn't really sure. So then in terms of pricing and cost, you'd feel good about using both the TI part for the analog and the on part for the digital.
Yeah, yeah.
Okay.
And I think that, you know, if you're going to use one regulator, okay, so you say you're going to use 3 regulators and you're going to use 1 on and 2 TI, so you can save a little money on the on. That's
Yeah.
not that you're wasting your time, because you're trying to save 20 cents. So it's just I guess I'm going back on what I said, is using 2
Oh.
different ones. It's like there's not enough difference in the performance, I think, to warrant using the cheaper part that's a little noisier. So
Okay.
I guess I would use all TI parts, because then you have one less bomb part to deal with.
Yeah. All right. All right.
If you use one of each, or two of one and one of the other, then both of them have to be in stock for your board to be able to be built.
That's true.
But if you use only one, then only one has to be in stock. But and they have 10,000 of them, so do your design quick and buy them. Then you don't have to deal with it, and they're only 90 cents or $1, so it's like.
All right. We're probably going to need probably 2 per board minimum.
And we're going to build what, 10 boards?
Yeah.
Because that's how many modem chips I bought, right? I mean,
Yeah.
data acquisition chips. I think I got 10, right?
Yeah, 10.
So
Because there's not going to be any other power here. We're not going to use any sort of filtering or gain stages. It's
no
just
amplifiers.
Yeah, because the Cirrus Logic part recommended filtering and gain stages, but with the TI part, you could kind of change with the registers whether you use single-ended or differential inputs. You could even change. They have AC and DC leveling, kind of like a scope.
Coupling.
Yeah, and it's automatically picked by the registers.
So are you planning to use external amplified antennas then to provide the filtering and the gain outside of the board?
Well, normally this would go into a sound card, which usually doesn't have. I mean, it has some filtering, but it mainly filters out noise.
Okay,
You know,
but
like
this
the
board
higher
takes the place of the
frequency stuff.
sound card. You won't be using the sound card if you use this board, right?
Well, this board is going to act like a sound card.
Right. So the antennas would have to either plug into a sound card or into this board, depending on what system you're using.
Right, yes.
So then you're going to have gain and filtering on the antennas, because you're going to need it for the sound card use case. Right?
Yeah.
Okay.
Yeah, because the goal is to around line level audio, and on the evaluation board, there's nothing in the analog path, except for some series capacitors that are jumpered in and out. And that's
For
on
AC or DC coupling. Yeah.
Yeah, because this part can be used with multiple microphones. That's one of the applications where you can have like 4 microphones or 8 or 8. So then you would need some sort of DC bias.
But you're not planning to put that on the board, are you? Because this is not really designed to be used with microphones.
Right. Yeah. I'm gonna avoid the DC bias all together. That's not going to be used.
Okay.
Um,
It's going to be meant to connect it to your antennas.
Do you guys mind if I say 7-3 for tonight?
Nope, we're
go
good.
ahead.
All right, thanks, Jonathan. Scotty, I will leave. Who wants to be in charge?
Okay, you can leave it with me. That'll be
All right,
fun.
I will leave you in charge, Scotty.
Thank
Do you want me
you.
to stop the recording or do you want to stop it when you're done?
You could stop it.
All right.